This is a quick little review about molar mass and mole conversions. These notes would be back in your Unit 3 notes packet if you need more detail. So we have to remember what a mole is. So 1 mole, and we're not talking the animal if you remember, is a certain number of particles. So we're talking atoms typically. So it is 6.02 times 10 to the 23rd particles or atoms I'm going to write because that's typically what we're going to be dealing with. And they weigh their atomic mass. So their atomic mass is how much they'd weigh. So for example, if I have 1 mole of magnesium, that would be 6.02 times 10 to the 23rd magnesium atoms. And all of those atoms, magnesium, would weigh 24.31 grams because that's the atomic mass on the periodic table. Okay, so we can use this to convert from grams to moles or to atoms, but everything relates to a mole. So we're going to do this conversion a lot. All right, so this is what you're going to see the most is the grams to moles, this conversion back and forth. You need to be able to do this. So basic conversion, let's say we have, I don't know, how about 0.75 moles of magnesium. All right, so if we remember, we set up our conversion factor, and you can set this over 1 if you'd like. And your units for here and your substance go on the bottom. So I put moles of magnesium on the bottom. And then the units I want to find, which in this case, we're going to find grams. So that's what goes on the top. Okay, so the units I want to find go here. And then the number that goes here, or the numbers that go here are your periodic table numbers because 1 mole equals 24.31 grams. So 1 for mole, and the grams is that periodic table number, 24.31. So now I'd go to my calculator and I'd type in 0.75 times 24.31, and I get 18.2325. I'm going to round this to 2-digit. Well, we'll do 18.2. We'll do 3 digits. Grams magnesium. So 3/4 of a mole of magnesium, right? 0.75 would weigh 18.2 grams. All right, what if we have more than just 1 element, though? We don't call that an atomic mass. We call that a molar mass. So this is the mass of a compound. So instead of just 1 atom, we've got multiple atoms, and to find the mass of the whole thing, we add them up. So let's say we have, let me get some more space here. How about MgNO3 taken twice? So this is magnesium nitrate. Okay, so we have to look at how many of each element we have. For magnesium, there's only 1 magnesium here. For nitrogen, there are 2. Remember what that number outside, right? That multiplies by everything in here. So there are 2 magnesiums. And for oxygen, I have 6. Because remember, this is like saying you have NO3 twice, right? So you have 2 nitrogens, 1, 2, and you have 3 plus 3, right? Which is 6. All right, so my mass of magnesium, right? We just did that up here was that 24.31. So each individual is 24.31. We only have 1 of them. Okay, so there's all the magnesium. Nitrogen, if I look it up on the periodic table, is 14.01. We're always going to round these to the hundredths place, 2 digits after the decimal. So 2 times 14.01 is 28.02. So that's the mass of all the nitrogen. And oxygen is 16.00. So 16 times 6 is 96. So I've got the mass of magnesium, right? Grams magnesium. I've got the mass of nitrogen. I've got the mass of oxygen. So if we want to find the mass of the whole thing, I just add them up. So 24.31 plus 28.02 plus 96. So the whole thing has a mass of 148.33 grams. MgNO3 taken twice. So now let's go back up here. What if we wanted to do something like this again? What if the question was, how many grams of MgNO3 taken twice are in, I don't know, let's say 0.75 moles of this one? So we set it up the same way, right? 0.75 moles of MgNO3 taken twice. Okay, we take our unit here, it goes on the bottom. And then the unit we want to find goes on the top. And then we look at our values, right here. This is the grams per mole. That's what we found, that molar mass. So the 148.33 is my gram number. And if it's per mole, that's per 1 mole. So our moles are 1. So we can see our moles divide out. We're left with grams. So I grab my calculator, and just like before, 0.75 times 148.33, and I get 111 point, I'm going to say 2. And then that's grams of MgNO3 taken twice. So there's your quick review of molar mass and then mole conversions with grams.